Alright, starting with question 30. Define hydrogen bonding. Well, before we define hydrogen bonding, let's actually define intermolecular forces. I'm sitting on my back deck, by the way, in case you're wondering, because you can hear the traffic. Intermolecular forces are forces between molecules. Ionic compounds have a really strong force between ions, and that's really technically kind of an intermolecular force, although they aren't molecules. So ionic compounds are the strongest. The next strongest are hydrogen bonds, which are really just a type of dipole. So, what's a dipole? A dipole is when you have a compound that does not share electrons equally. Hydrogen or water is the best example because it doesn't share equally, and this end is more negative, so you get a partial positive and a partial negative. A hydrogen bond is anything that is hydrogen bonded to oxygen. If it has a hydrogen bonded to a nitrogen or hydrogen to fluorine, it's just a super strong dipole. Something that is not hydrogen bonding but dipole would be an example of if we do not S2H, HS2. It's not good, children. H2S. It's really not good, children. Alright, sulfur would be bonded to two hydrogens. It's just like oxygen in that it has two lone pairs. So it would be shaped like water, with the sulfur sharing unequally with the hydrogens, but it would not be as strong of a dipole because the sulfur and hydrogen do not make hydrogen bonding. Alright, the last kind is what we call London forces, and those are temporary dipoles, or instantaneous. Okay, all molecules have London dispersion forces. Unsymmetrical molecules have dipole. Unsymmetrical molecules with hydrogen bonded to oxygen, nitrogen, or fluorine have hydrogen bonding. All right. So, define hydrogen bonding. A dipole between hydrogen and nitrogen, hydrogen and oxygen, or hydrogen and fluorine. Which could show hydrogen bonding? Well, anything that has hydrogen bonded to either nitrogen, oxygen, or fluorine. Hydrogen bonded to carbon? No. No hydrogen at all. Here, hydrogen's bonded to an oxygen, so this guy has hydrogen bonding. This is blocking part of the words, but I can tell you what it says, and you can read it on your own sheet. What type of molecules would have London forces? Any that is the only force they have, any non-polar substance. Polar means it's got a pull, non-polar it doesn't. Molecules that have dipole are going to be polar molecules, which means they're usually not symmetrical. All right, 33. Hold on. Question 33. Which of the following properties would indicate that a substance would have weak intermolecular forces? Weak forces means they can't hold on to each other. Now, let's review. London are the weakest, then dipole, then hydrogen. So anything that's going to be weak is going to be nonpolar. Okay? All right, what do these terms mean? High heat of vaporization. That means you have to add a lot of energy to get it to evaporate. If you're having to add a lot of energy to get it to evaporate, it's got some intermolecular forces. So this would indicate strong. A high vapor pressure. Vapor pressure is the pressure in an enclosed substance. When we did the ideal gas law, we had to take into consideration the water vapor pressure. Water vapor pressure, if something evaporates easily, it's going to have a high vapor pressure. So again, if it can evaporate easily, it's going to have weaker forces. High boiling point. Once again, if something's going to hold on to the particles, you're going to have to add more heat. So this would be indication of a strong forces. All right, we'll stop there.